Hello. In this video, we're going to be talking about something that we've sort of neglected a little bit up to now, and that is tables. Tables are a key part of data communication, even though they may not look quite as flashy as visualizations. But they're really important. A lot of information needs to be just given out in tables. Some information could be just effectively given out in tables. And there are, of course, ways to do tables well or poorly. So let's talk about some of those things. So a lot of the same principles that we've been talking about for everything else that we've been doing applies to tables too, right? You want to have a story to tell. You want to focus in on the information that's really important, and you want to present it in a very clear way. So what are some of the things about tables that can make those things difficult to accomplish? Well, for one thing, because it's very easy to add lots of information to a table, there's a tendency, sort of a temptation almost, to put everything on the page. We know that we want to focus. We don't want to do that. So it's important to think about what is the information that really needs to be in this table, and how can I present it very clearly. And that doesn't just go for the kinds of information that's on the table. It also goes for how much information is on the table, right? You could just take your whole data set of millions of observations and put it in the table. But nobody would want to read that, right? So you want it to be the case that if you're presenting somebody with a table, it needs to be the case that they actually want to see the results in a particular row of that table. Otherwise, you should probably do it in some sort of visualization that's going to more efficiently present the overall picture, right? Tables are good for when you really want to see an individual data point. They're less good for seeing an overall pattern, although there are some ways to use tables to show patterns, but patterns are often better presented with visualizations, whereas tables are good for seeing individual data points. You want to make sure that you actually have a reason that you want to see individual data points. That's why, for example, tables are often used for things like top 10 lists, right? Because you want to see all 10 of those things and all of the information about them. Or if you go to Amazon or something like that and you compare two different products, you're going to see a table of information that says, here's this product, does it have this attribute? No. Does it have this attribute? Yes. And so on and so forth, right? You actually are interested in each data point. I want to go to this row and see the information about this particular data point, and I want to do that for a number of different data points all at once. And that's going to be a really good place to put in a table. So how can we, let's walk through the process of taking a table that is bad, it's not going to be very useful for us, and that we can present it in a little bit more of a clean way. So here's an example of a bad table. First of all, it's got so much information on it, I can't even fit it all on the screen. Second of all, that's in terms of the number of variables that it is, and also how long it is, right? So this is every single country in the world is in here. You know, if this was the appendix of a report, then yeah, sure, maybe you'd want to list every single country in the world. But if you are presenting some sort of story that you're trying to get across a point, there's no way anybody's going to get any information reading through your entire table. Some other issues. Not everything is clear here. So for example, what's PPGDP? You might guess that GDP has something to do with GDP. These are countries, after all, they have GDPs, but what's PP? Is that per person? I don't know exactly what that is. That should be very clear, right? I shouldn't be using the names of the variables that I have in my statistics package. I should be using, English language variables, or whatever language you have to be presenting in. So that's one thing here. Even the ones that are clear, I should probably, capitalize, make it look nice. The numbers are not formatted properly, right? I've got like I got 6 places after the decimal point. I don't need that much information. It's not helpful to anybody. It's just a lot of extra space there that's not being particularly helpful. I don't even have that much precision, right? After the 3rd decimal place, everything is just zeros. So I'm just sort of, I'm trying to make it look like I have more precision in my data than I actually do. Also, there's something, you see those row of NAs there, those are some missing observations. That's things that I don't have data on, right? So why is that in the table in the first place if I don't have data on that particular row? As somebody who works with data all the time, I look at that and go, oh, well, now I know that they're missing data. But if you present that to a general audience, they might not know what NA means. Are we trying to say that region does not apply to American Samoa, right? It's not applicable. That's not really true, and so we have a problem there. So there's a bunch of things we can do to clean this up. So let's take one step. And first of all, we're going to cut down the number of variables that we're going to be showing in this table. So you want to be concise in terms of what your tables are presenting, because again, unless you actually need all the information, you can probably tell whatever story it is that you're trying to tell in a much more concise way with just a couple of variables. So what are the really important variables that you need to show? So here I've cut things down to just country, GDP per capita, and the percentage of the country that is urban. And so we can think of the two different things going on in these, like what these variables actually are. So on one hand, we have what are called identifier variables, in this case, country. So when I'm looking in a table, like I said, I'm generally wanting to look up a particular row of that table and see what the value is in some columns, right? So the identifier row columns are the variables that I use to figure out what row I want to look at, right? So if I want to learn something about a particular country in this table, I would look in the country column, because that's going to be an identifier. There could be more than one country column. So for example, maybe I have multiple years of data for each country, and maybe I want to have all of those years in there. Now, then I would use the country and the year to look up the data that I'm interested in. Aside from the identifying variables, we have, of course, the data variables with actual data in them. Those are the values that we have. We can also give everything a little bit more context. So here I've shown what's going on here. I've actually named the variables so you know what they mean. You don't have to guess that PCT urban means percentage urban in the country, or that PPGDP is per capita GDP. I've also capitalized things, and I've given it a table, right? A table needs a title. I've given it a title. Sorry, a table needs a title, and this is telling me what's going on. It's also telling me the story, right? Hold your audience's hand, let them know what point it is that you're trying to get across. And so what this is saying is that this is a table that's going to show us that which of these countries are rich and urban, if we think that those might be good targets for whatever company you happen to be working at. We also want to make sure that we can format our numbers, right? You don't want to just put those numbers on a table and leave them like that. That's lazy, and it might not be helpful, right? So if we go back to this GDP per capita in terms of what, right? Is that dollars? Is that euros? Is that something else? Is that pounds of gold? I don't know. And so we don't know. So we need to value that. And also the percentage urban. 23, okay, I can figure out it's 23% as opposed to like 0.23. But again, the percentage sign would make it more accurate in terms of just giving across the information that we need. In R, you can do this with the scales package. Is a good way of formatting numbers the way that you want. If you load up the scales package, there is, for example, a dollar function that will format your dollar values as dollars. There's a number function that lets you specify the number of decimal places, and will add things like commas for long numbers. Lots of things like that. In Tableau and Excel, things are done for you. You just need to tell it how to format. You click on the number, you do edit axis in Tableau, and you tell it, and you edit the scale, and you can tell it what kind of number you want it to be. In Excel, you right-click, do format the cell, and you can figure out what you want it to be. So here we've now formatted it. We've got dollars on the per capita GDP, so we know that it's dollars. We've got the percentage sign on percent urban. We still have that NA in there, which is too bad. And we also have way too much data, right? This is every single country in the entire world, probably not what we want, so we can go a little bit further. We want things to be short. So let's figure out what is the actual relevant data that we want here. Often you will see a table, if you have a lot of information like this, either maybe you'll stick an extended version of the table in some sort of link or appendix and just show maybe like a top 10 of whatever it is that you're looking for in the actual table that you present to people. Good way of cutting down the amount of information that you want. You can sort a table in Tableau very easily. You just click on the column. In Excel, similarly, you highlight the data, you click the sort option. In R and dplyr, you can use the arrange function to sort however you want, and then you can just take a certain number of rows that you want. Again, that's fairly straightforward to do in all three of those. In R, you'd use slice. So here, I've cut it down to just the most urban and richest areas. So I've sorted it by percentage urban and how rich they are to just pick out some ones that are particularly wealthy and urban, which we think that those are particularly good. And this also lets me cut down on the story, right? I don't need to say, hey, look at this table, now go hunt for some ones that have high urban and GDP percentages. I'm telling you, hey, these are the top 5 opportunities for expansion. It's much more actionable information, valuable information if that's what you're looking for, because I've done the work for you, right? I don't need you to go hunting through this big data set for me. Lastly, we can just do some nice formatting stuff. So for example, a very common thing you would do nowadays is stripe your tables. So most table producing software will have an option to create stripes, where you just have the different little shading for every different row, so that you can very easily find which row you're on and follow it across so that you don't get lost. It's just sort of a common thing. I would also recommend getting rid of most borders. You don't need a lot of borders in a table. You can do without them, especially if you have striping like this. So R Markdown was not cooperating on this, so it's still got some borders on it. But generally, I get rid of as many borders as I can, maybe a couple of horizontal lines at the beginning and end to sort of mark off the table. Very quickly, I'm also just going to show an example of a table. So I just went to 538 and just pick the first random article and look down to see if there was a table, and indeed there was. And let's see what they're doing with their tables to see how they're following these things. So this is a table about net change in total employment over the past couple of months. The crisis has been going on. So first of all, it's going by sector. So it doesn't show me every single sector. It cut down to a short table to pick a couple particular industries that might be particularly strongly affected. It doesn't tell me how they're picking those, so maybe that would have been interesting to know. But whatever it is, we've isolated some that are particularly interesting to whatever story is being told here. We have a small number of columns, so I would want to look up, hey, here's construction, here's how jobs have changed in construction over 1 month, 3 months, and 6 months. It's a clear column indicator. It's showing me changes, and I can tell that it's showing me changes because it's got both pluses and minuses, and it also says net change. But even if I didn't read this title right here, I could tell that it's not just saying there are 20,000 jobs in construction, it's saying there have been an additional 20,000 jobs in construction. Because it's using both plus and minus, it's really holding my hand here in terms of helping me interpret the data. Also, it's doing something that we didn't do, which is bringing in additional information to help us learn the story. Now, in this case, it's color. So they're color coding the cells based on the values in them. Right? A deep blue number is a very good thing. A deep red number is a very bad thing, which really draws our eye to where the really big changes are and helps us figure things out a little bit more clearly. All right, those are some basics of tables. You want to make sure that they're clear. You want to pare down the information as much as you possibly can. If you really have to show everything, then toss it off into an appendix or a link, or you maybe click a button to show the entire table, but cut down the information that you can. Make sure that things are formatted nicely, both in terms of the numbers that are in the table itself and also the table. Maybe there's some striping, maybe there's some sort of shading. You can use other sorts of information like color, or you could do some stuff with like font size and boldness, but I would stay away from that. Color is probably about as far as you want to go. It's fairly intuitive as a way of encoding additional information. And that's basically it. So go ahead and make some cool tables. Thank you.